There's a long history of computer scientists referring to themselves as wizards, whose programs are like spells written in cryptic language that many people can't understand. Well, I kind of resonate with that. I feel like the biologists are more wizard like than the computer scientists. For instance, the lab that we're doing today is hey, if we have some cells and some DNA and we shoot a lightning bolt across it, maybe the cells will start to glow. And in fact, this is what happens. And it's called electroporation. It's basically using an electric field to create pores in the cell membrane so that small molecules like plasmids or other molecules can get in. And so that's what we're doing today. I won't know until a couple days from now if it actually worked. Hopefully it did. But basically, you have a circular piece of DNA called a plasmid, and then you have some cells that are prepared in a special way that we'll get into. And by creating this electric field and having these pores open up, you have the plasmid flow in so that the machinery of the cell can start to transcribe and translate the genes that are on that plasmid. Now, one thing that just I started the day off with, because I like to say everything that I did because, I don't know, for posterity, is I first made some bacterial glycerol stocks of the two strains that I work with, which is NEB stable with P-glow and without P-glow. And that's just so that, months down the line, if I need some more NEB stable and, my auger plates are all dead or whatever, I at least have something in the -20. I did want to explain the reason why you add glycerol to these stocks in about what I've seen 15% volume is that it disrupts the nucleation sites of the ice crystal formation. So if, the ice is growing in this crystal structure and there's this glycerol and it gets in the way, then the ice crystal won't be as big and thus doesn't have as much of a chance of destroying a cell membrane or something. Then the other thing is it lowers the freezing point. So less of the water, I guess, actually freezes. The other thing that I did is I just made a 50% glycerol stock because on top of, this freezing point and this nucleation site thing, it's also helpful in the process of preparing them for electroporation because one, glycerol is apparently membrane permeable, so it can get into the cells. And because of that, it reduces the osmotic stress of basically the procedure of making them ready for electroporation, which is called making the cells competent or electrocompetent. All that is to say is that the main way this whole electroporation works is that you have a little cell, some cells and some plasmid in a solution, and you put it in this special thing called a cuvette or an electroporation cuvette. And it basically has these metal contacts on the side, and then you have your liquid in the center. And then when you put a huge voltage across it, it will, and huge voltage, I mean like 1.8 kilovolts. Like it's not like 20 volts. And anyways, the whole thing about making them competent is you don't want any ions in that solution because if there's ions and it conducts, you're going to get an arc and the solution is going to boil and it's going to destroy everything. Like all of the cells will die. And so you're not going to have a successful transformation. So the procedure of making the cells electrocompetent is you basically take your, original solution that's in like lysogeny broth medium, which is very ion rich, has tons of salt in it, tons of other stuff that's going to conduct electricity, and you wash it out. And now I got a procedure that said you could just wash it out with like DI or Milliq water, but I was reading a little bit more, and the reason that you don't want to do that is you're going to dry out and dehydrate the cells a lot, and that's going to just make them more prone to death. And the reason for that is osmotic pressure, as I was talking about earlier. If you have, if you're flushing all this water out, then water is going to be drawn out of the cell